In this video, we will cover how to set up CAN channels on the VMAX 4000, both using the Model 4080 power module CAN input, as well as the optional Model 4060 4-port CAN input module. To begin, I will navigate to the System Setup panel, and then from there, I will navigate to the tab labeled CAN. For a brief introduction here, the way that the CAN setup works is you map your channels in the table on the top of the screen, and by default, we are allowed about 250 channels worth of CAN. And at the bottom of the screen, this is where we will actually determine which CAN ports we are using. So interface 1 would represent the 3-pin LEMO connector on the 4080 power module. Interfaces 2, 3, 4, and 5 would represent ports on a 4060 CAN input module. Now on each port, we have the ability to change the CAN protocol that we're using. So you'll notice that there are a few different ones that can be selected from depending upon the type of CAN protocol that you're using. We can change our baud rate. There's also an FD data baud rate, which would only be available on our 4060 CAN FD module. And there's also provisions to turn on a built-in 120 ohm resistor. Again, this would only be available on the 4060 module. And then we also have a selector for listen-only mode, where we do not announce our presence on the CAN bus. There are some circumstances where this is beneficial. There are other circumstances, like when using OBD2 protocol, where this will not work and that our presence on the CAN bus must be recognized. So to go through a couple of quick examples, I'm going to start off with using OBD2. Now OBD2 has some standard signals messages that should be common on most vehicles that you interact with. Again, most gasoline vehicles, some of the hybrid and electric vehicles would not have some of these signals as they relate to engine signals. But if I click on the OBD2 button, that will launch a screen here that will bring in a bunch of predefined PID values that we can see. Now, in order to take one of these signals and get it over to the CAN screen, it's just as simple as clicking with my left mouse button, dragging over to the channel where I want to add it, and then dropping it. You'll notice when I do that, it does turn my log rate to fast, and it also turns global slow on. Both of those I could modify if required. Something else that can be done is we can actually take an entire message and drag an entire message over. And when we do that, you'll see that it's actually going to take all of those signals and bring them over. Now, some of these may or may not be functional on the particular vehicle that we're looking at. The CAN cable that links supplies that features a 3-pin LEMO connector and then an OBD2 connector would plug into the diagnostic port of most passenger vehicles. Now, I do want to note that all of the signals that I'm currently interacting with are presently set to go to the physical interface 1, which we currently have set up as our 4080 power module. Now, I do not have a 4060 CAN module installed on this particular hardware rack, but if I did, we would be able to map some of these other interfaces to correspond with where we would want to obtain that data from. So for example, we may have the CAN cable plugged into the diagnostic port underneath the dash of the vehicle on interface 1, and then on interface 2, we might be interacting with a CAN-based sensor that's plugged into the 4060 CAN module port 1. Okay, so also worth noting, as I've mapped some of these channels, or I've added these channels, these are of the OBD2 protocol. So I need to make sure that under protocol here that I select the proper protocol. So I want to select OBD2. And when I do that, you're going to notice that my listen only mode, which is currently turned on, is giving me an error message. And that is because OBD2 messages cannot be requested in listen only mode. OBD2 messages function by the device asking for a value and then it being returned. So listen only mode must be turned off. And what you will see right now is that I am actually transmitting out requests, and those are increasing here. And you will notice that we are not actually receiving any messages back. And that is because I am not actually plugged into a vehicle right now. Now, to demonstrate using a DBC file, I'm going to go ahead and delete all of these CAN channels. And when I do that, it asks if I want to delete or cancel. So I'm going to say delete. So I'm going to kind of start over from scratch here. Now, to use a DBC file, I need to change my protocol to simple CAN. I am going to turn listen only mode on. And I'm going to set my baud rate to 500 kilobaud. From here, I'm going to click the Load DBC File button. And when I do that, it will bring up the same window that I was using before. And I want to click on the Load DBC button here. Now, once I do that, I'm going to go ahead and navigate to a DBC file. Now, typically, a DBC file would be supplied by an OEM vehicle manufacturer. And generally speaking, this is proprietary. So unless you have access to this, this isn't something that you're going to generally find available out on the internet, for example. Now, to protect any proprietary concerns, I'm going to use something from a Speedbox speed sensor made by Race Technology. Now, what you'll notice when I open this is that we have a number of different messages. So the message would be the yellow envelope that we're looking at, and then there's a individual signal inside of it. So you'll see we actually have quite a few of these. Now, what I did want to point out is that you will notice that next to each signal there is a color-coded symbol. Now, most of these are blue, which is good. What I do want to show is an example where the signal is red. Now, in this case here, let's open this window so we can see a little bit better. As I click on one of these signals, it is going to give some additional details over on the right-hand side. And we'll see that this error message right now is that degrees per second, which is how this particular signal is being defined in the DBC file, is not recognized by ProLink. Now, to correct this, this is pretty easy. All I need to do is right-click inside of this field, and then I need to go and select the correct unit class. So this is a angular velocity, and degrees per second in ProLink is signified by D/S. So if I go ahead and select that, you will notice now that these signals have all turned blue. And this will persist next time I close the software and reopen. Alternatively, the DBC file could be manually manipulated using a program like Text Editor or WordPad. And the degrees per second could be replaced with D/S inside of the DBC file. Either way is completely valid to do. So as we showed before, there are ways to simply grab an entire message and drag that over, or on an individual signal basis, I can also do this. So it is important to note, as we start adding CAN signals to our table here, we again want to be mindful of the interface that we have selected. This would be the hardware port that we are actually trying to get these signals from. The baud rate, the type of protocol that we're using, whether we have listen-only mode on or off. As you'll notice at the moment, with listen-only mode on, my transmit is not increasing. Something else worth mentioning is that at any point we should be able to see the value of this data as we are receiving it. And we can see the unit in which the Dvc file dictated that those signals came in under. Now you will notice if you right-click in the unit column, I do not have the ability to change the unit here, but in any other screen where we add this channel as a live display, or put it on a gauge, or put it in a target bar, for example, we are able to manipulate the units there. So for example, anything that is in the linear speed unit class, like in this meter per second example here, could be changed to kilometers per hour, miles per hour, or any other unit inside of that same unit class. With CAN channels, we do have the ability to map those, just like we do with all of our other channels. And when I right-click here, because the unit class here is a linear speed, it's only going to bring up map channels that coincide with that same type of unit class. So for example, if I go down to percentage here, you'll see only ones with percentage are going to show up in addition to these spare voltage signals. Now we don't have to use map channels. If we don't, we would just have to know that physical channels 551 through 797 are the channels that we are using. Inside of the CAN module here, inside of the CAN setup screen here, we do have the ability to load and save CAN setting files. And when we do that, we'll see a file extension of .can. So these can be referenced and saved for easier test setup in the future. It is also important to note that on the power module, as well as the 4060 CAN module, there is an LED next to each CAN port that would indicate if there are issues or not. So it does go either green or red, depending upon if we are receiving a data stream. It is also worth noting that on many modern vehicles now, that in order to get access to the CAN bus, there may be some security measures that have to be accounted for. Many vehicles now have some type of security device between the diagnostic port and the CAN bus that would prevent any unwanted traffic from either reading or writing to that CAN bus. Generally speaking, your OBD2 protocol for some of the basic type of signals that should be available on most vehicles is accessible. However, using simple CAN protocol with a DBC file may not be functional until that architecture has been either unlocked, or there could be some rewiring that's required to go around security devices. I hope that this video was helpful. This concludes our CAN setup for the VMAX 4000 using the 4080 power module and the 4060 CAN FD 4-port input module. Thank you.